Hello YouTube, welcome back to the bench. Today we're going to do something a little different. Instead of doing a takedown on a walkthrough and a reassembly guide, we're going to take some time to go over why guns work. There's a distinction in the world of firearms repair between the role of the armorer and the role of the gunsmith. And there's a lot of basic rules of thumb that your gunsmith is going to be able to fix anything because they've got the tools to both remove and replace metal. So gunsmiths will generally have mills, lathes, welding equipment, and the skills to use them all. And an armorer is sometimes derogatorily referred to as a part swapper. And there's a lot of truth to this, but there's an awful lot of overlap in the job, in the two jobs. The armorer is often trained in one or a line of guns. You might be a Colt armorer, which would make you more knowledgeable than most gunsmiths about Colt firearms themselves, but you would still be limited in terms of what you would be doing for repairs or enhancements to simply, removing damaged parts and replacing them. You can't really reshape metal or make new parts without the access to and the knowledge and skills of all the more advanced machinery. But when it comes to the knowledge set and how to work on guns, there starts to be this middle ground between the two. And that is when you become a broad range armorer, or on your way to learning the full trade of gunsmithing, which is there are more guns out there than you will ever run into or even hold in your hands, but you never know what someone's going to bring into your shop next. So you can start off being an armorer and learn everything there is to know about a Glock or a Smith & Wesson or whatever other firearms brand you're into. But at some point, you'll come to the realization that there are a lot of manufacturers of firearms around today, and there were a lot yesterday. And this goes back for over 150 years of firearms history, and you will be brought firearms from all areas across that history. So you're never going to learn them all, and so you don't try. One of the things that they drive into your head when you're actually starting gunsmith school is that you have to be able to pick up a gun and that you've never heard of the manufacturer, you've never seen the firearm, and you have to be able to repair it correctly and skillfully and all the rest of that. And that's what the challenge of the job is about. And so you don't learn individual guns, you learn systems. You learn, why do guns work, how do they work, how do you recognize the necessary parts that go into making a gun in any gun that comes across your world. So one of the first things is the parts that are in just about every gun, because without them you wouldn't have a gun. Guns are at their heart very simple mechanical machines. They have a small number of functional required parts. There's a trigger that you're going to pull, and then a whole bunch of stuff in the middle that ends up with something that strikes the back of the firing pin, the back of the primer on a cartridge, and a barrel, obviously a frame to hold on to, and everything else kind of optional. So those parts, those main functional parts between the trigger and whatever it is that's going to pop that primer, is called the fire control system. And it's the most important system to learn off the bat because it's where all the moving parts are, and it's where things will break. And if you understand the concept of the fire control system, then you will be able to recognize its parts in any firearm you encounter. So that's what we're going to talk about today as an introduction to this concept, is simply fire control systems. Now, we're usually working on semi-automatic firearms these days. This is obviously different in revolvers or single action revolvers, but any semi-automatic firearm is going to have the same four fundamental parts, and that consists of a trigger, which is most people would recognize, a firing pin, which I haven't actually taken out of this one yet. I'll pop a firing pin out here for good measure so we can actually show everybody as we go. So like I said, there's the trigger, and then there's the firing pin. And then you've got to get whatever force is required to push this forward hard enough to dent that primer translated. Now, you'll notice that most triggers don't have a 14 or 15 pound pull. Ancient, revolver, or full double action revolvers are, but that's because you're doing more. Trigger pull, especially in single action mode, tends to be very light, which means the trigger is not what's actually applying force to the firing pin. It's not how hard you squeeze the trigger that controls how hard the firing pin comes forward to hit a primer. That would make things terribly unreliable. So there's going to be a system of a lot of other parts in between these that's going to make this connection actually work. And so the firing pin, or in striker fired guns, you'll have a striker, but it's the same essential concept. The firing pin is what we're going to talk about today. And as it looks a bit like a nail, it's not too illogical that the part that's going to actually hit it really hard enough to detonate the primer, is called the hammer. So you have this thing that looks like a nail and a piece called a hammer. And without too much rocket science training, hopefully we realize that the hammer hits the nail and not the other way around. Bing. So now we've got some logic here. This is the part that's going to actually hit the primer. This is the part that's going to hit that. So something that you do with the trigger is going to have to be connected to this hammer in some fashion. And then the hammer itself is going to be under a whole lot of spring tension. Now, there's a big old spring in here that's always pushing up on the back of that hammer. So there's a whole lot of force being pushed up on this hammer. But, when you're holding the gun, the hammer stays cocked until you push the trigger. So the part that sits between a trigger and a hammer is called the sear. I don't know the etymology of the word, so I'm not going to try and guess where it came from. But the idea is that there will be a notch on the hammer. If we set our hammer here, maybe it'll be a little clearer. There is a very small notch right around here. There's a big notch up here. That's called the half cock notch. That's a safety mechanism. But there's a very, very light notch in this. And this piece that is the sear has got a hook on it, this big curved end that comes to a very controlled flat surface that's at a very specific angle. There's actually a couple angles on it, but its whole purpose in life is to catch that notch on the hammer and prevent the hammer from rotating. So I'm going to slide some of these parts into the frame using the outside so we can see what would be going on if we were actually on the inside without having to have x-ray vision. So the sear pin and the hammer pin, that's the actual holes they would be going through, except they'd be on the insides. And what you're going to see here is that that sear can sit and line up with that notch. And when that's there, no matter how hard I push up on the hammer, it can't rotate because the sear is in the way. Now, our trigger, if the trigger would come back and push the back of the bottom side of the sear backwards, well, it's going to rotate around this pin, which means the top side is going to come forward. And once it comes forward, it's no longer going to hold the hammer back. So that's how things work. The trigger is going to push the sear out of the way and let the hammer fall. So every gun has these three parts in some fashion. They might have different names for them. There'll always be different shapes, but there will be a trigger, there will be a sear, and there will be a hammer. And these are always, almost always, three separate parts for some pretty good reasons. The number one being about semi-automatic fire. So this is cocked, it's sitting here, the trigger pushes that out of the way, hammer comes forward, hits the firing pin, round goes off, now you get your recoil stroke. That's going to send the hammer back into the cocked position, but your trigger is still pulled. You're holding that sear out of the way. So when the slide goes forward, what stops the hammer from following it back forward? The sear's not catching it. So in order for guns to be semi-automatic, something has to disconnect the trigger from the sear, so that the sear, there's always a little spring tension on the sear that's going to want to push it into engagement with the hammer. But so long as the trigger is pushing it out of the way, you've got essentially an automatic weapon, not a semi-automatic weapon. The hammer's going to come down as soon as the slide closes and try and set off another round, often successfully. Technically, this is called hammer follow down, and it's a failure condition of a semi-automatic weapon. But the concept is that how do we get these things back to the point where the sear can catch the hammer again, so that you then have to let off the trigger and pull the trigger a second time to get a second shot off. And that is a piece called the disconnector, because that's its job, to disconnect the trigger from the sear. And in a 1911, as I was using to illustrate, these parts are more than a little bit counterintuitive. The disconnector actually sits inside the sear, and it can move up and down a little bit because unlike the sear, which has a hole exactly as big as the sear pin, this guy's got a big square hole, which means he's got some slop in it that he can move up, down, and all around, and that's crucial for the job that he does. Oops. So we're going to put these guys together as they would appear in the firearm. Slide our sear pin through them all and talk about what really happens when these are all in there. So the first thing to be aware of is that the big leaf spring in a 1911 is got three legs. One of them is pushing on the sear itself, and one of them is pushing on the disconnector. And what the one that's pushing on the sear is doing, ignore the disconnector for a moment. I'm just going to stick a finger here and hold it out of our way. The one that's pushing on the sear is pushing on the bottom leg of it, and it's pushing it forward. So it's pushing the sear, pushing the bottom forward, which is pushing the top backwards. So that big leaf spring is always putting tension on the sear. So if something is not actively pushing the sear out of the way, pushing against that spring takes over and pushes the sear into that position. And remember, that's the position where it can catch the hammer. So as long as nothing else is bothering the sear, that spring keeps it so it's going to intercept the hammer. And we know that the one thing that's going to knock it out of the way eventually will be our trigger. So let's talk about exactly how that works. The other spring, the middle leg of that leaf spring, is pushing on the disconnector itself. And if I show you how this disconnector is shaped, the back of it is flat, and that's because that's the part that actually touches the trigger. And when I said the trigger pushes on the sear, it does, but it does it through the disconnector. This is how they're actually oriented, where that flat part disconnector, the blade, is actually between the trigger bar and the sear itself. So when I push on the disconnector, I'm also pushing on the sear. And the other important part about it is that where it sits in the gun, that leaf spring is the middle leg is pushing this on a ramp. The back of the disconnector is a ramped surface, and that means that something like the leaf spring, if it's just pushing against this ramp, it's going to want to push it upwards. The leaf pressure is straight down, but because it's an angled surface, the result of pushing down on it is that you actually move it upwards in the gun. So that leaf is always wanting to push the disconnector up further as far as it can go. And so remember that these guys are joined together here with the pin, the sear pin going through them. And remember what those two springs that we just talked about are always going to want to do. The disconnector is always going to be pushed up, and the bottom of the sear is always going to be pushed back. So sear is being pushed into engagement with the hammer, and the disconnector is being pushed up as far as it can go. And if you notice, when it's as far up as it can go, it just barely catches the bottom of the sear. And if something were to push it down, it would actually pop underneath the sear and lose contact with the sear. And so that's important because that's how this whole thing functions. When it is in the up position, it's acting as an actual connector between the trigger, which actually pushes on the bottom of the sear, the spade of the disconnector, and that's going to in turn push the sear off. Then something is going to come along and operate the disconnector, pushing it down temporarily. And when it gets pushed down, then the sear can pop back into engagement with the hammer. And so all of this has to eventually reset, and that happens when the trigger comes forward again, because now that spring that wants the disconnector to be moved up will actually have a chance to. So right now your trigger pushes back against it, and so that's offsetting what the leaf spring wants it to do. When you let your finger off the trigger, the leaf spring is going to kick into action, bringing it both forward and, as we discussed, up as high as it can go. And now you've got a reset of this system. So the sear will be able to push against the hammer. The disconnector will be between the sear and the trigger, and high enough up so that if you pull the trigger again, you'll move the sear. So let's talk about that whole thing in the order it happens. So from the position where the gun is cocked and we're going to pull the trigger, trigger bar comes backwards. This is the bar of the trigger. Obviously the trigger always has to move force from where your finger's going to be to where the moving parts of the gun are, and in this case it does that by just wrapping around the entire magazine. The magazine in the 1911, when it's up in there, it actually slides right through this piece. That's it just sits in there. This piece is ever so slightly wider than a magazine. So trigger is going to come back, push back on the disconnector, which pushes back on the sear in turn, releasing the hammer, allowing the hammer to come forward. The firing pin is struck, the round goes off, the slide comes back, and there is a piece in the slide that's going to operate the disconnector by pushing it down as that slide comes back. So the disconnector is going to come back as the slide comes out. Disconnector goes down as slide goes back. The minute the disconnector goes down, you're in this situation where the disconnector is now under the sear. The sear is free to move under its own spring tension, and it wants to lock in with that hammer. As the hammer goes further and further back, the sear will pop into that notch and stay there. So now the slide has gone forward, but the hammer has stayed back. And this is the position of the disconnector and the trigger. The trigger is still pulled, so it's still pushing the disconnector down and straight back and overcoming its spring. We're going to let up on the trigger and let the other spring take over, and that spring pushing on the disconnector is going to bring it forward and up. And once again, you've done a complete reset at that point. That's why it's called the reset. You hear a click when that happens as it pops up, and the gun is ready to be fired again. The magazine has dealt with chambering another round, and we'll get into the relationship between the magazine spring and follower, the shape of the barrel, and how that extraction and feeding works. But right now we're just talking about fire control systems. So the trigger is going to need to put force onto the sear. Now if you also think about the forces involved, that leaf spring doesn't have to be particularly strong, because it just has to move this into the way of the hammer. The way that these angles are cut in the hammer and the sear, as long as they touch, no amount of force can cause the hammer to slide by the sear. They're cut in as what's called a negative angle, which means that the harder the sear and hammer are pushed together, they lock into each other. A positive angle would mean the more pressure you put on, the more likely they would be to come apart. So the angles that this metal is cut at makes it so that the more force that the hammer exerts on the sear, the harder it is for the sear to move out of the way. So you don't need a ton of force coming from this little leaf spring to push that sear into place. You really just need it to be in the path of the hammer. Once the hammer runs into it, the force of the hammer itself keeps anything else from happening. It keeps it all locked up there. So trigger through the disconnector is going to push on the sear to take the sear out of engagement with the hammer. Gun will fire, recoil stroke happens, bringing the hammer back and the disconnector down. That lets the sear come into where engagement with the hammer again, and holds the hammer back as the gun finishes cycling. When it finishes cycling, there's once again room for the disconnector to pop up. So once our finger comes off the trigger, the disconnector spring carries it back into the upward position, and you hear it click into place with the sound that most people refer to as reset. So, trigger, disconnector, sear, and hammer. These pieces will exist. These same four will exist in some form in every firearm ever made. And a firearm can't work without them. If you pulled the trigger and you didn't have a disconnector of some sort, and it was an auto-loading firearm, it would simply go and have the hammer follow down on the very next stroke, and it would either become automatic or just if the hammer fell fast enough, it would become an automatic firearm. If it fell too slowly, and it's usually going to fall slowly because it's going to follow literally the slide forward, and that usually prevents it from getting up enough steam to actually hit the firing pin hard enough to go off. Normally that hammer has a lot of air in between itself and the firing pin and isn't actually following a big slow moving slide forward, so a hammer follow down is usually not enough to set off a round. From a safety perspective, you assume it is, but from a real world perspective, it's generally not going to happen. So the question is then, well, what do they look like in other firearms? You may have seen firearms that don't appear to have anything even vaguely like that. So how do you find these parts? Well, that's what it's about to be a gunsmith or a versatile armorer, is to know that if somebody hands you a firearm, maybe you've never seen one like it before, it's going to have these parts in some fashion. Looking around for a good example one. I don't want to get one that's overly complicated. Well, let's talk about how they look in a striker fired gun. That's probably a good way to go next. So I'm just going to slide this guy off to the side for a little while here. I'm going to keep my main pieces out in case we need a example. But we're going to actually switch to everybody's good old favorite, the Glock. Reach around here. So a Glock is not got a firing pin. It instead has what's called a striker. And it's very, very similar in concept, except that the instead of having a large hammer spring, and in the case of the 1911 here, what's going on with the firing pin? You notice the firing pin had a spring as well. But if you look at what's going on in the 1911, that spring is pushing the firing pin backwards. That spring isn't gonna make the firing pin hit the round. It's gonna stop it from hitting the round. And the only thing that can overcome this big spring is a massive hammer spring. In a striker fired gun, you have those two systems combined. So there is a spring on the striker, which is the equivalent of the firing pin. It's the piece that's going to come forward and pop that primer. But the spring in it is actually pulling that forward very, very hard. If I pull back on the tail of a Glock striker here, if I can do this, I have to pull back against a large, because when I'm pulling back, I'm compressing a spring in here, and it's a heavy spring. I want to say it's like 5 newtons, and I can't remember for the life of me how that translates to pounds. So when you let off that striker, it comes forward, and that's the equivalent force that a hammer would exert on the firing pin. So this striker is kind of a combination of the hammer and firing pin in one piece, and that's what striker fired guns are all about. They also give a different separation between the frame and the slide. In a hammer fired gun, if the slide is off the gun, it's pretty much impossible to have a round in just the slide part of the gun get set off, because there's nothing that has enough force like the hammer would involved on the parts that are left in just the slide. Whereas a striker fire gun, that's not really true. There's a warning on the box of every striker fired gun that usually there's a sticker on the side of the slide itself when you get it that says, "Caution, the slide can fire with the frame detached." And the reason is that if I put a live round in here, and I did my same little thing with a screwdriver or even my finger, pull this back and let it go, I'd have to hold the firing pin safety at the same time, but the point is, that's it. I don't need a large external force. I only have to overcome its internal force by pulling that back and letting it go. And that would set off a round, which means I could walk around with this and pew, kill people, or at least cause a probably large painful disaster in my hands, but in fact send a round going in roughly a direction that I wanted it to go. So we're going to take that striker out to look at it as a separate piece and compare it to some of the other bits. As mentioned, this spring is normally under pressure, and when you are cocking it, you're putting it under more pressure. So what it wants to do is carry that striker forward with a vengeance. So we're going to take those out so we can just look at the firing pin itself, or striker itself. I'm going to try and keep calling it a striker. It's a terrible habit that I call them firing pins. Again, it's got a tip where it's going to hit the primer of the round, and then it usually has a tail. So the striker, there are different striker designs in the world, but generally there's a tail, and the tail is designed to actually dip below the level of the rest of the slide so that some piece in the frame can be in charge of pulling it back and letting go of it. And you guessed it, those pieces in the frame are going to consist of a trigger and a sear. So we take all the extra parts out of our Glock. And set the frame aside. This is the trigger system, and we'll take it apart a little bit more. Actually, we're going to go ahead and pop the trigger bar apart, because that's really the piece we need the most. In a Glock, the tail of the tail of the striker is going to be held back by this particular ledge on the trigger bar. So a trigger is obviously, the trigger, but a trigger bar implies other parts or other functions along the path of it. And this one has a bunch of them, but primarily it has a surface which engages with the striker. This little flat, it's actually slightly raised. They call this piece the cruciform piece. I'll let you guess why. And no, it's not because Jesus designed the Glock. The trigger is going, when you pull the trigger, this is going to move back, which means it's going to pull the striker back with it, and then something else is going to make this trigger bar move downward and therefore release the striker, at which point it can come flying forward and hit the primer. Now, just like in the hammer-fired gun, the slide is going to come back and then it's going to come forward. So if this piece is still down and out of the way, that means that striker is still going to be forward, and when that round comes in and the chamber closes on that round, it's going to get struck. And again, you've got an automatic weapon instead of a semi-automatic weapon. So somewhere in the Glock, there is yet again a disconnector, so that after the shot is fired and the trigger bar is pulled the striker back and then dropped off of it, as the gun cycles, something has to let the trigger bar pop back up so that when the striker comes forward, it catches it again. So something pushed it down so it could fire. While it's cycling, another action is going to happen, causing a disconnect so that the striker can catch on the back of the trigger bar. Now, because of how this works, it's kind of a little bit backwards. Rather than needing something to disconnect the trigger from, or excuse me, in this case, the sear from the hammer system, what you have is that they are already connected, and then they disconnect to let the shot fire. As the gun is cycling, you need something to reconnect them. So Glock actually named their part a connector instead of a disconnector because it works a little bit differently. And so what's going on there is this piece here. When the trigger bar is in the gun, there's a spring. The spring that's in that body is pulling up, and it attaches down low on this back piece of the trigger bar, and that means that it's going to be pulling it backwards and upwards, and the upwards is an important part of that. So this piece sits like this, and that spring is going to want to bring it all the way up, so it has some up and down motion that it can do. It can move up and down right about here a good bit, and that good bit is important because that's enough to get it off of the sear. So when it's at the right point in its little universe, it can be high enough to catch the sear or low enough to miss the sear. So high enough to catch, low enough to drop off of it. And so what's going on? That spring again is pulling it upwards. Don't worry about the fact that it's pulling it backwards. That's actually counteracted by the enormous force on the striker. So that offsets it a little bit, but the striker is actually going to win because while these guys are engaged, there's a lot more force on the striker trying to move forward than there is from this little dinky spring trying to pull it backwards. So what this little dinky spring ends up doing is simply holding it upwards. So when you pull the trigger, you're going to start the whole thing moving backwards. So right now, it's being held up by the spring, and it's moving straight back until it runs into this piece here. And this piece has a ledge. It's a shelf, an angled shelf. And when it hits that, this nice rounded surface of the trigger bar the trigger bar can no longer move straight back. It's hit an angled piece, and it's still going to be pulled up as hard as it can by the spring, but it can't. Your finger is still going to push it backwards harder than that spring can pull upwards. So as you're pulling that trigger, this is where you actually feel. So when you pull the trigger on a Glock, it's essentially a two-stage trigger. The first stage, you're actually cocking the striker back even further than it automatically is cocked. And the second stage is when you run into this angled piece and begin to have to overcome the spring's upward force, and pulling it straight back forces it to ride down this shelf and moves it down. So again, when it's up, it's catching hold of the tail of the striker. When it runs into this piece, it's going to move itself down and release. So how do we get it to come back up without letting it come forward? Because our finger is pulling it all the way back here. That spring still wants it to come up, but this shelf is in the way. Well, if you look carefully at this piece, from this side, you'll see that, yes, the shelf is there, but it also has this bumper piece up here. And that there's space between the top of this metal piece and the plastic. Well, what that space is for is so something can push against this little bumper pad and push it in. And what happens if you push it in? If you think about what's going on with our trigger. Our trigger came straight back in the highest up position that it could. It ran into the shelf and it got pushed down. It wants to come back up, but the shelf is right there in its way. If something were to come and push this down, now I can come up and pop up right over that shelf. It's hard to do when you're on carpeting, but essentially, once that shelf is out of the way, I can slide past it. That shelf does not come out so far that if something pushes it out of the way, the trigger can now be pulled all the way up by that same spring. And that means that it's going to catch the striker on the way back from the slide cycling again, and it's going to be high enough that it can hold it. As you let go of the trigger, that striker spring overcomes this little flimsy one, and the flimsy one still holds it upwards, but it can't really hold it back anymore. The striker is going to push that sear forward, and you hear that click, it resets. This piece comes back into position so that when you pull the trigger again, you will run into the ramp again. Ride down the ramp, the gun goes bang, this disconnect stroke happens, and the trigger pops up. The sear is caught again and carries the gun, or carries the trigger forward, giving you your reset. And if you're wondering what is it that pushes on this, well, if you were ever looking at your Glock slide, you'll notice that it's not symmetrical. And I'm not just talking about the firing pin safety being on one side. I'm talking about it comes straight back on this side, but on this side there's this extra shelf that comes in an extra almost 1/8 of an inch. And what you'll find is that when the gun is put together, I'm going to go ahead and take this guy out for illustration purposes. This is that connector that we were talking about. That connector sits right about like this. Not sure what the best angle for you guys to see that is, so I'm going to try and figure it out. Yeah, you can see that bump sits there. So when the gun is cycling, the very first thing that it has to do is this curve right here is all the space it has to immediately push that on towards the inside of the gun. And it only lasts a little while before it has room to pop back out again. And at that point, you have brought the trigger the rest of the way back. And now, because the connector got pushed out of the way, that little spring has pulled the trigger bar back into the up position. The gun cycles back forward, and it ends up repeating this. So you kind of get a second chance in case somehow it didn't disconnect the first time. And then finally it comes into its normal resting place. But it can't actually get all the way in there because, remember, our trigger bar has now come up and is going to be blocking it. As we release the trigger bar, then this can snap back towards the side of the gun where it wants to normally rest. So if you look really carefully at your Glock and you've shot it enough, what you'll see is a little line traced into the side of the slide that is the connector following that path. So it actually ends up wearing a little bit of the way into the slide. So putting all that together again, put the connector back in, and like I said, they call it a connector instead of a disconnector because when you're talking about striker fired guns, it makes a little bit more sense. Remember, it attaches to the bottom of the trigger bar, so once this is in place, that spring is pulling as far back and as far up as it can. So it wants to pull the trigger bar above the little ramp. If I pull it forward, now it can get caught on the ramp, but if I let it go up and back, that spring that's what it wants to do. So if we drop that into the frame, and I'm just going to stick the locking block in there and the trigger pin just to hold stuff together, so we can actually take some fake shots with it. Now remember, I said that with nothing else attached, this little spring is going to win, and so if we bring the trigger all the way forward and we disengage the trigger safety, so the trigger safety is actually what's holding it now. This spring wants to pull it all the way to the back. The trigger safety, that middle leg being forward, causes the back of that same leg to get just in the way of the frame, and it becomes too wide to fit back in. However, once we defeat that, spring tension alone is going to bring the trigger all the way back, and the spring in question is that little spring in here. And what it wants to do is bring that piece as far back and as far up as it can get. Now right now, nothing is pushing the disconnector, or excuse me, the connector towards the inside of the gun. However, when it cycles, the frame, or excuse me, the slide is going to push that right into the inside just enough. So if I do that with Mr. Screwdriver here, and I'm just going to push in on that piece, you're going to hear a pop, and you're going to see the disconnector rise up because that spring wants it to move up. Oops. There you go. As soon as it came in far enough, the whole thing comes up. And now I'm on, this is that curved back of my trigger bar on the outside of that angled shelf. As the gun is cycling now, the striker is going to come back and want to overpower that little spring, and it will succeed. And I want you to watch what happens to both the connector and the whole trigger bar, but focus mostly on the back of it there, as I use the striker to pull the sear forward. And I just put it in there as if it had just come back with the rest of the slide, and it's going to pull forward. As soon as it moves a little bit forward, you hear the pop of the connector pushing back out towards the right side of the gun. Once that pop happens, when I let up now, notice that it can only come so far back before it runs into the shelf again. And when it does that, it has to ride the shelf back down. Now, I didn't have a pin in the back, so it actually pulled the whole trigger mechanism up. So once again, we're going to put ourselves in the disconnected state, and we're going to illustrate the striker. I'm going to pull the striker forward, and now we're going to simulate pulling that trigger. It's going to come, and it's going to be forced down, 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 down until it pops off the striker. So the other thing to watch there is how that sear, especially as you're keeping your eyes on the sear itself, as it comes back, it stays up as long as it can, but then right at the end of the stroke, it has to follow the cant angled piece of the connector down into the body. So that's the up, and then that's the down. Up, down. And again, the disconnection to keep it from going automatic is the part of the slide that pulls that temporarily towards the inside, allowing that to come up even though the trigger is all the way back. So the trigger is all the way back, but it's now lifted up and will catch the sear as the sear comes forward, and that brings it back into battery. So, same parts. You've got a trigger. You've got the piece of the piece that holds the hammer back, and remember the hammer is essentially built into the firing pin. When you get a striker, the one piece has two ends that serve both purposes, and the big hammer force spring is around the striker. So the sear holds back the tail of the striker, and then there is a disconnection between the two so that they can come off, and then a reset so that the gun can interrupt fully automatic fire. Once it's reset, now you can fire it again. So same parts. These are going to exist in every firearm out there, because that's how they work. They can't work without these parts. So no matter what we pick up, or what you pick up, that's really what you should do, is look at it and say, well, I know where the trigger is. I can probably figure out where the firing pin is. If it's a hammer, those are usually pretty obvious too. Let's go on a little bit of a scavenger hunt and find the other must-exist parts. The disconnector and the sear. The sear, again, is the surface that doesn't bear the force of the hammer, but does prevent the hammer from dropping by simply getting in the way of its physical movement path. I'm going to throw this guy back together, and I'm going to go grab one other gun that's got yet another different mechanism, and we'll look at how that works. The idea is that as you go through every gun out there, you start to look for these pieces. And that's really your best intro to how firearms work. Now, there's a lot of other systems, and we'll have videos on those in time, but this is really the big one to think about when you're first getting into this, because it's also the first place that you're likely to tinker. And you'll probably make some disasters in said tinkering, because one of the things you'll want to do is change how that trigger pull feels. And while that is an incredibly popular thing for people to do to firearms, it is also wildly dangerous, because it's very easy to accidentally defeat safety mechanisms, or to go so far as to interrupt that fundamental system and cause the disconnect to not happen, and turn your gun into an accidental automatic firearm. And unfortunately, the law does not distinguish between a machine gun that you manufactured on purpose and a gun that turned into a machine gun due to a mechanical failure. If you're sitting on the range with that gun that you just tuned up the springs to get a little lighter trigger pull, and suddenly you pull the trigger and it lets 4 rounds off, the ATF agent who happened to be practicing in the lane next to you has a decision to make, and that decision could put the next 25 years of your life behind bars for you, and just make for a really, really bad afternoon. So, putting the Glock aside, I'm not going to reassemble the 1911 yet. We will have a 2-second reminder course right now. We will go back to this one more time later, at least. All these things in position. The hammer is caught by the sear. The disconnector is being pushed up. And the trigger is going to eventually want to push backwards on the disconnector spade. So I pull the trigger. I touch the disconnector, which in turn touches the sear, pushes them forward. The hammer falls, the gun fires. The disconnector, as the slide begins to come back, the hammer will start to cock, and the disconnector will be pushed downwards by the slide. Now the trigger and the disconnector are underneath the sear. The sear can have its spring pressure resume, which means it's going to catch the hammer. As the slide goes forward, the hammer stays back. We're now in this position with the disconnector down, the trigger back, and a spring that wants to return the disconnector to the up position as soon as we get our big knobbly finger off of the trigger. We take the finger off the trigger, and this spring kicks in, bringing the disconnector up and back behind the sear where it belongs. So that if we pull the trigger again, boop, bumps into it, and they move together. And give me just a moment to find some other firearm. Let's see what we got sitting over here. Smith & Wesson. This is a Smith & Wesson M&P 40 in this case. This is another striker fired gun. These guys got kind of busted on this gun by Glock because they really did. The slide itself is just a bit of a Glock knockoff. It wasn't the M&P series, it was the one that preceded it. I want to say, not SV, it had an S in it somewhere. But the point is that these parts are going to look real similar to the parts in a Glock. You've got a trigger bar. In this case, the firing pin safety is at the back, not at the front, but it's, other than that, it's still a trigger bar. And when you pull that trigger, what you're going to see, in this case, this is the sear. So when we pull the trigger, this part here is holding on to the tail of the striker. It is a striker fired gun. So the striker is held up here. When we pull the trigger, the sear drops down into the body of the frame, and there's now a clear path for it to go forward. The disconnect stroke pushes this down. Oops. Where does the disconnector go? I may have pulled it too far back to have operated that. Oh, I'm sorry. I said that wrong. Disconnector does not push this gun down. Disconnector pushes it over. So sear is back. Disconnect stroke bumps this to the outside. You remember the Glock bumped it to the inside? In this case, bumping this piece to the outside, sear pops up under its spring tension. As I come forward past a certain point, now the trigger bar can pop back to the inside. Released, as the slide goes by, it's going to push this out. As my finger releases off the trigger and it comes forward, it will eventually get to the point where it can pop underneath the sear again, which is my reset. I pull the trigger, down it goes. So, trigger, sear, and a disconnect. Reconnect, trigger, sear, the hammer up here doing its job, disconnect for semi-automatic, reset. And the striker here is essentially identical to the Glock system. You pull back on it and it's got a ton of force pulling forward, all maintained inside the slide. And again, a firing pin safety, but we'll get into safety mechanisms another day. Same system though, trigger, sear, disconnector, hammer and firing pin. What else is over here? Oh, I'm not going to do the H and K because that's got such a complicated firing pin system. What is this? My buckmark. Buckmark work for this. Buckmark has an internal hammer. If we took... Yeah, we can take enough of the buckmark apart to illustrate it. I think I just need to take the top off here, so there's my handy dandy, hopefully vaguely correct size tools. Oops, that's way too big. The Goldilocks problem. This one is too big. This one is too small. This one is just right. Actually, none of these are going to be right because this is a metric set, and Browning happens to be an American company. And my yellow ones are out of eyesight. Let's see. That's not it. Here we go. Here's some standards. Oops. Let's not knock the studio lighting over. So, Browning Buckmark, fairly classic gun, relatively ancient design. Since Browning's been dead for 100 years, go figure. There was the Browning Buckmark, the Colt Woodsman, and then eventually the Ruger Mark 1, 2, and 3 1022 pistol series. Which were all big, heavy barrels, target 22 pistols. If you make a 22 pistol, have a nice heavy barrel, or even just be heavy in general, the round is so light that it transfers almost no force back over to you, the shooter, and you can really make a amazingly easy to control firearm. Of course, remember exactly what you're doing here. Disassembly doesn't have to be a challenge. All right. So, in this case, we have a firing pin akin to the one that was in our 1911. This is not the firing pin spring. This little guy down here is our firing pin. It's a 22, remember, so it's a blade style firing pin that comes forward, and the bottom half of that blade crushes the edge of the rimmed round of the 22. And notice that when I push it out, spring pressure brings it back. So again, unlike the striker fired guns where the spring wants to take it all the way forward to set things off and you're holding the spring back, this is going to be a hammer fired gun. Something big and heavy has to hit this really hard to overcome that spring pressure and send it forward. And so in here we will find a hammer, and this guy here is that hammer. So when I pull this trigger, there's a sear inside here that we're not going to be able to see from this side, but it's going to push out of the way. Right now it's holding that hammer, and the hammer's got a good deal of force on it, and boom. Now, actually I lied. We can see most of that if I just take off this one side panel. And so let's play Illustrations Are Us. Grab your relatively closely sized screwdriver. Take this side panel off. And I just realized I'm working below the level of my camera. I apologize, folks. We'll put this back in the light here so that everybody can share in the love. So, trigger, something to point with. Obviously our trigger, and when we pull our trigger, parts go flying everywhere. Forget about all the goofy parts. There's spring tension in weird places on this gun. I cannot tell a lie. Alright, so I'm going to have to keep a finger across these just so they don't go flying out of the gun. So I apologize for my big fat thumbs. Alright, so the trigger is moving this trigger bar. And if you note towards the back of it, trigger bar is moving some piece back here that sits right behind that hammer. And you'll also notice there's some shiny pointy ledges on that hammer because in fact this is the sear, and in this case it sits behind the hammer and it grabs the back of the hammer right here. So it's all happening inside the gun and below the level we can see, but we can see enough of these things to actually watch them function. So give me just a second to keep that reset. So what actually holds this together is that side plate. So the important part is you understand that the trigger is moving the trigger bar, and that what you see back here in this little notch here, this piece of metal is the sear going all the way across. And then this big bump here is going to be what acts as our disconnector. Because when the disconnector goes down, what you have there is the ability for the sear to move back freely when something pushes on it. So when we pull the trigger all the way forward, we're holding that sear there. If we just try to cock the gun now, the sear is being held out of position. It cannot catch the hammer. So this bump, as I said, this bump on the trigger bar is the disconnector. Something's going to push that down, and you're going to see the sear have its own spring pressure, bring it backwards. And since this is all kind of upside down, backwards is the part that's going to let it engage the hammer. So like I said, pushing this down, you'll hear a click and see the sear go backwards. Not a lot, but a little. And that's enough so that when the hammer is cocked, whoops, apparently it's not. Ugh. No, it's just my fat fingers can't cock the hammer at the same time. I got to put this side plate in because it's what holds all these parts flat. And obviously, my chubby fingers not up to the task. So throw this back in. I'm about to do something that's a major no-no in firearms. Never use a tiny little screwdriver to put in a real screw. You frag the head of the screw, it makes it ugly and a mess, and there's no reason for it. Get some good gunsmith screwdrivers. Always use the largest screwdriver that completely fills the blade, or the blade path in the screw. Alright, so now that this is in place, we'll be able to manipulate these a little easier. Pretty sure you can still see it all. So with the trigger pulled, the trigger, this back part of the trigger bar is what brought the sear forward. The disconnect here, as the gun cycles, you see this bump right here is where the disconnector can sit. It will sit here when the gun is in battery, but when it goes to cycle, now that's going to ride along here, which holds it down. So once the gun is fired, the next thing that's going to happen is that pushes down, and the sear was able to move back. And do that again. Sear able to move back. And now I'm going to cock the hammer. And what I was doing wrong before is this hammer cocks fairly deep into the gun. And I might need one more finger to properly illustrate this. There. So, my trigger is still pulled. You can see the trigger bar is now underneath the sear. So the reset will happen because it can't come up. It's being blocked by this edge of the sear until the trigger bar moves it back to get behind it again. It hasn't reset. So as I come off the trigger, that trigger bar is going to be allowed to move backwards, and as it clears the back of the sear, you'll see this leg pop up. Boop, just like that. So pulling the trigger is going to have that same leg pull the sear forward and let the hammer go. Then the disconnect, and whoops, while everything is still held, oh, so hard, so many pounds of pressure on that trigger. Alright, so the disconnector got pushed, and the hammer got pushed back at the same time. The reason I'm struggling with that is because the disconnector stays pushed all the way down. I'm letting up on it too soon, so when I just let up on it, it tends to get caught there, and so when the sear doesn't have a ton of pressure on it, and so it's not actually moving. The sear is free to move now and engage the hammer, except I don't have there. If I push the disconnector down the rest of the way, you heard it click. That click was clicking into place, so that's why. The only time that disconnector is allowed to be in the up position is when the thing is completely in battery, which is like this. So this disconnector is now in that up. Yeah, we can do this. We're going to pull that trigger. We're going to actually operate the hammer and the disconnector as they would have operated in the gun. And now when the thing comes forward, what you're going to find is that the whole thing worked. The disconnector was held down long enough that the sear could catch the hammer. I'm still holding the trigger. Hammer did not come forward. I let go of the trigger bar and it pops back over. So once again, the whole thing, as I pull, the hammer comes forward. As the gun cycles, the disconnector is held down and the hammer passes the sear. The hammer is caught by the sear, and then the disconnector is allowed to come back up when the gun is all the way in battery. Finger comes off the trigger bar goes back and pops up. So, all the parts are happening in. We've got our trigger, and it's going to pull the sear out of the way of the hammer. The hammer is under a ton of force, but the sear, as we saw, there's not a whole lot going on there. The sear moves, relatively freely back and forth. Whee! So again, the critical part is that the hammer force is not being transferred over to the trigger. And then the bump on the trigger bar acts as the disconnector as the slide pushes it down, allowing it to come out of contact with the sear. This is the sear spring that's tipping it back into wanting to engage the hammer. So, hammer, sear, trigger, disconnector. No matter what gun we take apart, we will find these same parts. And this includes rifles. If you go after a bolt-action rifle, you won't have a disconnector because it's not self-loading. I failed to put the magazine spring back in. This is what I always thought was a strange design on Browning's part. All these parts just floating in the right side of the gun, and the left side isn't much better. They all have to kind of be put in carefully in the right order. There's a magazine safety in this gun, which is this big long stick. If the magazine drops out of the gun, it's got a hook around the trigger bar that's going to pull the trigger bar down. So that's what this big spring is. It's just a big wire with a hook, and the magazine, when it locks into position, pushes it up. It's on a spring that wants to pull it back down. So when I pop that magazine, what you're going to see is exactly that. This hook has pulled the trigger bar down. When it's in the down position, it can't move the sear anymore. So, no matter how much I operate the trigger, I'm nowhere near my sear. This back leg is what has to engage the sear. It's just not there. So until something is put in there that's going to push that forward again, and that button is the whole thing, it no go bang. However, what that means is you've got, this is the magazine spring, so that's what's pushing the magazine release back out. Without it there, it comes out of the gun. So magazine release, this is the last part that goes in. The trigger bar itself also lays on. The trigger is just this little pin, so the whole thing is to just pick the distance that it wants to rotate at, that gives it the amount of motion that it needs. So you move the back end of the trigger, has a, what is that travel space from here to there? That's just short of a quarter of an inch, but that translates to a very small amount. So that force is multiplied here across the fulcrum, and but at the end of the day, what it means is that our trigger bar, she don't move very far back and forth, but she don't need to. So again, the trigger bar can come out. This spring is what creates the reconnection. The spring is what wants to push this this bumpy disconnector pushing the trigger bar up means pushing the disconnector back into place when it's in the right place in the slide. So again, using an angled spring against an angled piece of metal, that's how you create that. And that's all this is just this little V spring sits in there. But for the safety thing to work, this big hook that sits in here, you got to get the trigger bar hooked on that. There's a little ledge there on the trigger bar. That's where that thing rides. So when you go to put this all together, if you don't put the magazine in, it becomes a little bit more of a challenge because it's being pulled downward by a significant amount of force. So one of the ways to make it easier, put your magazine spring in, or magazine in, so that now that bar is pushed up. It makes it a little easier for you to put the trigger bar in. You can kind of guide it under it without too much force, without bending stuff, and that's the idea. So get the trigger bar in place. Make sure it's actually on the pin that operates it. So the smart person puts that part on first and then slides this in. Now it's bouncing up and down because the V-spring's not in. To get your V-spring in, start it with the end in the frame and then bring the other end over it. Don't forget to lay the magazine spring over everything else. And then you screw the big ass rubber slide on. If you ever monkey up the grips, or you try and find replacement ones, they have to be made really perfectly. This has to be a solid, non-yielding rubber surface. So while this is, or metal, wood would work too. So well, this is rubber. It's a hefty gauge rubber. It's not a bendy rubber. If you bent this, it would probably actually snap if you were strong enough. Because when we put this on, it's going to compress this spring a little bit, providing some tension there, and it's going to hold everything else flush with the side of the gun, so that these pieces can operate. Without this here, none of that works. And how Browning ever figured out that he could pull all of that off with only one screw to hold it together, I don't know. Man was a genius. So we'll just chalk it up to being a genius. It doesn't have to be over tight or anything. You don't want it to warp, but at least now you can see all the pieces doing their job. Disconnection. Hammer goes back. Sear catches it. reconnect. Good for the next shot. Again, we'll watch. If I drop the magazine, you'll see the whole trigger bar will get pulled down. So all I'm going to do is thumb the magazine release off, and boop. Now, no matter what I do, I'm so far away from the sear, it don't matter. I said we weren't going to get into safety systems, so I should have stopped, but I was too excited. So let's reassemble this bad boy and see if we can spot another one hanging out in the shop that might provide a good lesson. Whoops. Putting things in right side up, always a benefit. Just a big, handy, smart thing to do. That's another strange thing about the way this goes together. You really are just laying these parts in and then just screwing a big plate on top of it all that does the rest of the legwork. It's just kind of weird, but it worked. And if anything I ever design is still around 100 years later, I'll be a happy man. Or at least a proud one. A proud papa. What other hammer-fired guns do I have over there? Since I got it back together, stick him back in his little fancy-dancy case. Ooh, fancy. Oh, alright. Bear with me, YouTube, for just a second. We're going to go find one more hammer-fired gun. Because we can. Oh, maybe a Macaron. I bet you've never seen one of them. Those wacky Ruskies. So, Makarov is one of the 3 9mm calibers that are still common today. And that they're actually, still modern guns manufactured to use them. Makarov was obviously a Russian design. The 9mm or Luger round, go figure, a German design. So safety first, take out the magazine and make sure. Oh no! What have I done? Make sure that you remember how the gun operates. Yeah, it's been one of those days. Alright, so take down the Makarov. It's a design that was used by Walther and other German manufacturers. The trigger guard actually is got a locking piece, that top pit that goes up. That's what holds the whole thing together. So when you pull it down out past where it would normally be. The other thing is you can't rack this gun with it in the safe position. So you have to have the safety off to rack it. And then the slide, I just did that off camera where you couldn't see. Wasn't that nice? Alright, so I'm tired of crushing my fingers. I'm going to use a tool to sit in there and keep our slide out of the way and put this back together. Alright. That was terrible. Don't do this at home. Let me find something better than that punch. That punch was too small, and it actually did not hold it down far enough to do this properly. So I'm trying to find something larger to wedge in there. Actually, I can just push the punch on the back side, and that'll hold it just fine and dandy. So holding that trigger guard down with the safety off, then you'll be able to bring the slide back further than it would normally go, lift it up, and then off the gun. This is a fixed barrel, obviously. It goes nowhere, which means this is a blowback operated gun. Barrel doesn't tip, doesn't start the slide moving. The entire slide force comes from the round pushing its way backwards as the bullet is pushing its way out the front of the gun. So when you, that's what the earliest semi-automatics were before they invented the various other types of locking mechanisms to lock a movable slide into a slightly movable barrel into a very movable slide. The first ones, they didn't work that way. The slide, one piece of metal, round sat in there. Round gets detonated in equal and opposite force in both directions. So the bullet goes out with a great deal of speed and force, and at the same time, the slide is being accelerated backwards. Since the slide is much, much, much heavier, it accelerates slower. The bullet has time to leave the barrel, and the case is pushing back on the breech face as the case wants to push itself out as well. So the case comes pushing the slide back. Barrel itself just sits there like an idiot and doesn't move. And in this case, this is again a hammer-fired gun. We've got a big hammer, and I put the wrong glasses on. We have a firing pin. When the gun is on, when the safety is off, a well-placed hammer blow can reach the firing pin and move it in. I keep doing this completely backwards, and I apologize. Oh, Mr. Makaroff, it's been too long. What have I done? What have I done to deserve this? Maybe if I stopped pushing on it with such a giant punch, I could figure it out. Oh. I'm an idiot. Yeah. So the Makarov doesn't have a firing pin spring at all. Like the 1911 had a firing pin spring to push it back. The what else do we look at? Do we look at the SIG? Yeah, the SIG also a spring to push the firing pin back. The striker fired ones, the other way around, it's pushing it forward. This one, no spring at all, which means that the firing pin is actually just flopping around in there. And what that means is that the firing pin can come forward and just protrude and stick out. And the only thing that pushes it back in is a round getting chambered, which sets it in, which means it has to be a really lightweight firing pin. And it's a pretty good idea to keep the hammer off of the firing pin if at all possible. The way this safety works is it actually that's the fire position. It brings this ledge back, which is going to block the hammer from coming all the way forward. When the safety's off, it doesn't quite rotate all the way out of the way. But there is a big notch in the hammer that leaves room for it, and so it can come far enough forward to trip that firing pin. So I'm going to use a punch in here to push the firing pin in, so that you can see how much it actually protrudes here. So that's the firing pin when there's a round in the way, and when the hammer hits it, I've got to actually move the slide because the punch is at the other side. So like I said, there is a firing pin sticking out. So that's our firing pin. All the other parts are going to be in here. If I were really smart, I'd remember how to get this apart. And I do. I'm not sure how many of these we actually need to see. This is the last gun we're going to talk about, but I don't know how many of its parts we got to get to, because you know what? Actually, I don't even need to take the grips off. You can see everything in a Makarov right through the top, which is also a kind of neat design. So trigger, obviously, and I'm going to go ahead and set this one off so that we can illustrate some of the moving bits. This is a double single action. We're just going to talk about the single action really, but the key is that the trigger is moving this trigger bar. And so if you watch all the things that that's connected to as we go on here, you'll get a sense of how everything's going to work. So we're going to put the gun in the cocked position, and what you're going to see as I pull the trigger is this piece here moving. This is attached to the trigger bar. So as I move the trigger, this piece is moving. And what this piece is doing is it's lifting up on this piece. It comes into contact with this guy right here. And if you notice, this is your hammer, and there's your shiny part of your hammer. This is your sear. So I'm going to hold the hammer so it doesn't just go flying forward, and then when I pull the trigger the rest of the way, the trigger is lifting that sear up. So right now the sear is engaged with the hammer. If something were to lift that sear up, the hammer is now free to come all the way forward. And also all the way back. And look at that, nothing catches it, because what's the other part? We have our trigger and trigger bar. We have our sear and our hammer. Nothing is catching the hammer. The sear is still being held up because I'm holding the trigger. So there must be something. Don't let me space on this. Yes, something that when the hammer is back, hell's donkeys, I forgot where the disconnector was. Where in the seven hells? Maybe I will have to pull it apart to remember how the heck it worked. Oh, that's embarrassing. That's all the way embarrassing. So, I know mentally, intellectually, that the parts are here. What I apparently don't know and need to find is how they do their job. Well, ain't that a biatch? So like I said, a gun I haven't taken apart in 8 years, maybe 10. And I don't remember how it works, but I know how it has to work. I just don't remember how it does work. And I don't want to break my Bakelite here, so give me a moment to get these off without actually destroying the whole thing. I think they slide all the way back, yeah. Bakelite is that funny brown plastic from the early years of of plastics. It was a hard plastic, but it's fairly brittle. They would still embed metal in it for various tasks, like hanging a gun on things. But really, the older it gets, the more brittle it gets. So, if you have something with Bakelite, it is nice and sturdy. Just try and maintain it. Don't let it bake in the sun or other things that are likely to induce catastrophic failure over time. Whoops. It's always fun to watch the fat man think. Ah! The obvious. Always the obvious. Why for is it not obvious to me when these things happen? All right. So, after a rather embarrassing pause to remember how the hell it worked, we knew it had to work, so finding the piece was all it was. And the way we did that is, now here we're going to pull the trigger, steer is up because the trigger bar brought it up. What I was missing was that when the trigger comes up, when the trigger is pulled, this piece is lifting up to catch the sear. So from this side, you can see that the trigger bar has this groove in it that really matches and aligns with the groove in the side of the sear. As I pull it and it comes up, it catches the sear exactly, fills that shape, matches this shape. But this piece is tall. Down here, it's almost the same height as the sear, but once the trigger's there, it's not, it's tall. And if we look at the slide, right where that piece is this shape, which means once again there's space for something to be towards the middle, but when the slide is going to be moving backward at a high rate of speed, that thing that wants to be in the middle is going to get pushed out to the side. And it's not going to be able to come back there till the gun is all the way cycled. So what I should have been looking for is not something to push down on for my disconnect, but something that's being pushed outward. And the hint is that, yes, a piece gets taller when this happens. So, again, holding my hammer pressure back, pulling the trigger all the way, that disconnect is this piece here being pushed out to the side. And that takes it right away from the sear. Sear falls into place. Hammer can't come forward. So again, trigger is pulled, sear is pulled, or disconnect happens, and sear is engaging the hammer again. As you let up on the trigger, remember that this piece was brought up by pulling the trigger, and it goes down when you release the trigger. So as I release the trigger, it will eventually get low enough that it can catch underneath that piece of the sear and pop back towards the inside. And again, it can't do that till it reaches the cutout here where there's just enough room for it to do that. So once again, trigger, sear, hammer, and the handy dandy disconnector. So it had to be there, I just had to find it. And every gun is like that. So whether you've seen a gun before or not, if you look for the functional parts, you know it has to work. So look for the parts that make all guns work, and you'll have an understanding of them. Now the other thing that I have an understanding of looking at this one, there's some other mechanisms going on with this sear, most of which are related to some of the other functions. This gun has a decocker. The safety when you put the gun, when you take the gun from fire to safe, what you will see happening there is this piece, which is essentially flat and more or less aligned with the rest of the slide, that piece intrudes when you go to the safe position. So that's fire, and that's safe. This is going to basically come up as a big button pushing thing, and what button it's pushing on is the sear itself. It's going to bring the sear out of battery. So what's going to happen here is when I flip it over to safe, it's going to pull this part of the sear up and let the gun actually fire. Well, that's kind of the same as pulling the trigger. How is it a safety mechanism? And the answer is, well, at the same time that it went from fire to safe, watch what happens back in here with this piece. Now there's a cutout in the hammer where this piece can be, and the hammer can still come far enough forward to hit this firing pin, which is off to the side of it. But when I put it into the safe position, that moves way down. So now if the hammer came up, the hammer would hit it here instead of in the nice big opening, and she would no go boom. So if I put it back together to illustrate that, I'm going to show where that hammer actually lands. So, notice that the hammer didn't make it all the way forward. And if we look, it's not only does it not make it forward, you can't even cock it in this position, because that piece that normally is there, not only does it give the hammer enough room to come all the way forward, it's also not in the way of the hammer going back. When when this piece is flipped, it actually is going to get flipped into the path of the hammer. So you can't even cock it with the safety on with this gun. So again, the safety off is putting the safety on is also a decocking mechanism, and the only reason it's safe is because it is just dropping the sear to let the hammer come forward, but it also blocks the hammer at the same time. So, I mean, if you were checking it for timing and safety, what you would want to be sure is that there was not a point while you were moving the safety into the off position where it brought the sear forward enough to let the hammer come down, but somehow didn't get itself into the hammer blocking position. So I'm going to try and move this guy as slow, steady, and gradually as I can. And we're pretty far rotated. I don't think the hammer would make it forward yet, but we haven't brought that sear all the way off of the hammer yet. So that's how it's designed, is to not really get the sear out of the way till the part that needs to block the hammer is all the way in place. And that's smart, safe design. Now, as you saw, hammer could not come all the way forward, and I wasn't even all the way on. So yeah, they built this thing safe and smart. What else in here is worthy of discussion on that topic? So we didn't really cover double action. We really just stuck to single action. What's going on in double action is the same thing. There's just a second sear slash hammer engagement area. So when you're doing a double action, what's going to happen is the same part of the single action is going to work because that sear still has to get out of the way, but it's really not what's controlling it. So as we're doing the double action pull, what you're going to see is this is going to, again, lift the sear up and out of our way at this same time or just before something else lets the hammer go. So this doesn't actually like cock itself into the notch where the sear is holding it and then let it out. As a matter of fact, if we cheat and just hold the sear out of the way, we still have a double action pull. So without taking this one all the way apart, you really can't see it because this happens on the underside of the hammer. There are better guns to illustrate that. The SIG is probably a good example. But basically, you need beefier parts of your trigger bar because they have to grab that hammer way down here at the back of it and pull it hard enough to cock the hammer back, and then have some other mechanism which will pull to the point of losing engagement with the hammer. So at the same time it's pulling on the hammer, it's also getting less and less surface area in common with the hammer until finally it reaches the point where they separate and the hammer can drop. So timing wise, since the same thing is going to happen to the single action that happens when the single action is back here, it's the same parts work in it, they have to actually operate just slightly earlier than the hammer, than the double action stroke would do it, to make sure that things go really properly. So you have to make sure that the trigger would not release in double action mode till it was at least here in single action mode. So that's here: sears, hammers, disconnectors, firing pins, strikers, your core fire control group for any firearm out there. This applies to rifles too. I could whip out the AK, but I think we've gone long enough. So first system to become your first stage in learning about guns is to recognize those four fundamental parts.
sear, hammer, trigger, and disconnector, and find them in every semi-automatic weapon. They're never going to look quite the same twice, but functionally, they will always be doing the same thing. The sear will be holding the hammer back, even though the hammer is under a huge amount of tension. The trigger will move the sear out of that blocking of the hammer mode, and the disconnector will separate the trigger from the sear so that the sear can go back to doing its job of holding the hammer back.
And that's it for the shop today. Have a good one.